Thank you, Fanny, and I really would love to thank you all the sponsors for making this talk possible here in Baltimore. Well, thanks for your generous introduction to my work. And today I just want a very important thing to say, and is the gratitude to all my students, colleagues, and people involved on what I'm going to share with you. When I started speaking about the decision support systems based on artificial intelligence, I am always thinking about the complexity and, of course, how can we understand clearly if the system is at least nonlinear or non-Gaussian. So my background allows me to work not only in artificial intelligence, but also in Bayesian estimation. And from my perspective, I really would love to share with you the applications in health and defense, and I will try to clarify certain concepts at a different kind of levels. So first, we're going to discuss what machine intelligence means to me, and how can we work through developing new algorithms for decision making. The second stuff is something that may be common or you already know, but I really would love to discuss the difference between data, information, and knowledge, because of sometimes we are not using them so wisely. Afterwards, I will try to introduce you how can we understand the process of consciousness and decision making and the ethics behind this. As human beings and as a part of environment, we need to work for in the future. Then the information compression and the knowledge extraction concepts related to the entropy and the mathematical formula for what we like to call a very successful and very simple application. And then I'm going to move to the funny part, and I will show you some applications of different beautiful and important systems in my country. Well, when I am thinking about decision making, I am getting inspired by the complexity of the human being. And in artificial intelligence, people tend to think more on replicating processes. But I want you deeply to think about some things I am about to read. In order to have a conscious human, something that we like to call intelligent, we need to be aware of emotions, attention, feelings, intelligence, imagination, creativity, memory, forgetfulness, sometimes a new word, the synesthesia, anticipation, and cognitive bias. So if I am looking forward to develop decision-making processes based on artificial intelligence, what I need to do is to try to replicate the human processes behind the intelligence that we are claiming to replicate. So these factors I mentioned are a key for what I like to call successful developments, achievements, and algorithms through time. If you want to have more details of each part of concept, I will show you in the future afterwards, but please take note of the publications we have on the bottom of the slides. Well, yeah, and in terms of having a conscious human being, I had to realize what would be the technology for providing a good partnership in order to develop something that we called the human-centered mathematics. Human-centered mathematics is a concept and a framework that jointly reunited the artificial intelligence and the extended reality, looking for the enhancement of different kind of cognitive functions of the human being, tackling problems that may go from decision-making in command and control, health, and rehabilitation. By pairing two technologies, we are willing to enhance not only the user experience, but also the skills and the knowledge you can have from different environmental situations. We decided to work for humans and think from science, and the human-centered mathematics is the framework for what I'm going to share you in the future slides. Well, when speaking of decision-making, you are dealing with a problem concerning to personal opinions, personal background, personal experience from one side, or a bunch of people's different behaviors. So inspiring in terms of decision-making allows us to discuss not only how humans develop schemes, but also how different species collaborate. Intelligence for us is not only biased towards humans, it's also focused on how nature behaves. So we have been exploring collective intelligence in order to determine if we can replicate one specific specimen like superior one instead of having the best solution provided by a collective of individuals. Or in certain cases, why not thinking about teaching and learning in education processes, how can you help to replicate a really good behavior of a bunch of top students and help with that knowledge to other students? So these processes of decision making get complicated depending on how valuable the assets you are working with are. So if you are dealing with financial series or trading, is a completely different application if you're dealing with with intensive care units. And the physician's decisions are quite complicated in terms of your lives. So we think about life here, and we are aiming to develop the most profitable system to give the system the skill to help doctors the possibility to save your life and, of course, extend that kind of care in different scenarios. But what if you think about protect the assets of your country? And that's something that we as a researcher, scientist, and of course military people look for. To start with what we do specifically, I want to clarify why I'm not so machine learning driven researcher. I do truly believe that as a former control engineer, the data as an observation or like a measure of sort of the dynamics of the world is based on the outputs of the system. If you look at the world as a very complex one, you will have inputs, you will have state space that we like to call in control engineering and systems, and you have outputs. But the outputs are a vector that is mapped from this state space. So as an output, you don't have the full information about the dynamics of the system. You may have sort of information over there, but you may have some of the insights, but you wisely need to use the observations to infer about the proper state of the system. I can show you there in the slides how can you just use data to try to replicate a very complex phenomenon. All of you know the data set I'm talking about, but the interesting thing is that if you just approach the problem, such as machine learning stuff, you may just realize a topology or relationship between the data, but never will infer about the nature of the problem. In that regard, you can have all these beautiful visualizations of the data. So you say, oh, that's amazing. I love data. I need a data set. So if you look at this slide, what do you see? Think about it. There's a bunch of aircrafts. You look at meteorology. You look at a shape of a beautiful country such as mine. And you have a lot of data over there. What can you extract, understand, and realize about it? So data itself is not telling anything unless you have a human being to interpret in order to determine what is important or not. That picture says everything. So we have a very beautiful airspace, we have different routes, we have two seas, we have a very complex meteorology there, and we need to use it wisely. And wisely means how to defend and protect our nation and or how to preserve lives of people that is flying across my country. Information. So look at the two slides. Beautiful slides. Can you tell what is the important object we are dealing with in these two different pictures? You can see a bunch of shapes. Yeah, maybe there's a wall, and there's some clouds, and maybe some person walking down there. But I'm interested in the drone. Can you see the drone? Left up in red. So there's a bunch of information. So we have a super sensor, a thermal camera. It's showing everything, but it's not telling us nothing. And Maria pointed very well. So we need to extract what is relevant, the features that are relevant for the problem we are going to address. And in terms of trying to preserve the information, we need to simplify what we observe. So this is one case in which even if we have a super labeled data set, if we just work through the data, we're not going to be able to detect anything because of the problem may be focused on what we need to deal with. Another stuff that I like to call is knowledge, and this is a very carefully chosen example. For applications in chemical transport modeling and numerical weather forecast, we have a physics and chemistry models solved by numerical methods. That's something that we need to do. And as a differential equations, we need initial and boundary conditions. Data assimilation is the process in which you can estimate states and parameters, including information from sensors and outputs. The problem here is that if you have a three-dimensional +1 time space full of different grids or different resolutions, the problem escalates at tremendous level. The data assimilation process requires that you define a covariance matrix to take the probable, most preferable data close to the place you are going to estimate, and then getting the data and the covariance matrix, avoiding a spurious correlation between the data to acquire it into the model. If you think about it in a very simple way, if you're familiar with Kalman filter, what we do is extending the Kalman filter to nonlinear, non-Gaussian systems. But you would say, this nothing has to do with artificial intelligence, dude. This has all to do because we realized that if we knew very well the initial and boundary conditions, we may set up properly the covariance matrices. So what we did was use the numerical model, of course, to estimate the states. We use the data to get the information into the model, but we use previous knowledge about the system. The knowledge may be static or dynamic, and that's something that we need to take into account for our artificial intelligence-based decision-making problems. Well, before I go to the applications, I want to share with you a recent publication in terms of how can we, from a very humanistic perspective, develop mathematical algorithms and approaches. So this topic is called consciousness and ethics. And here is not my area of knowledge, but I want to share with you some findings we have. From humanities, there's a perspective that comes from philosophy. This is the Bloomberg's understanding of consciousness. And it says something that I've been sharing and discussing with some machine learning engineers or data scientists, that once you go to the technical stuff, just based on getting large data sets, training transformers, training machine learners, training anything, you're going to be in the technical side and you're going to be far away of the process of solving the problem. You have a senior leader researcher, a mathematician in some of the cases, but you're just doing things like in like art or like repetitive task. So what's your job? No, I'm training models. I'm building data sets. But are you aware of the nature of the problem you're solving? That's something I want to ask you because of you're not getting conscious of what kind of developments you are doing. You are working for someone else's that is at top of the chain, and he is designing the algorithms and the applications, but you are being just used as a matter of purpose for a very particular system. On the other hand, we have the Daston perspective. The Daston perspective goes from history. And yes, once you get into a technical job, you are subordinated. And where's your intelligence here? If you are developing a machine that learns from you instead of learns from the data, that's our responsibility. What I want to share with you guys is that once you are a developer of artificial intelligence-based systems, you are not just playing with a data set. You're playing with your understanding, with your knowledge. And the added value for your applications must be the way you understand the world. If you're not conscious about the kind of developments, or if you're not aware of the meaning of what you are doing, such as in the case of Rivas, you are not going to be successful. You should be taking into account what is the purpose of your artificial intelligence application. So, what I am inviting you to do is to take care of the ethics behind the algorithms. But you will say, no, I'm a computer scientist. Nobody is teaching me how to apply ethics. I guess that you're wrong. Once you understand the mathematics behind this, you will clarify what ethics means in terms of artificial intelligence. Here I got an example. 2 years ago, we all know, before the end of the world, we weren't aware about what kind of difficulties we may face in terms of clinical trials. Suddenly, as we had experience with highly complex images, such as the one I showed you when information slide came up, we decided to work together to tackle the COVID problem. And suddenly we had a bunch of papers of deep learners learning patterns in radiography. If you look at them, everybody was asking me, no, this is very successful, 90% accuracy, just go for it, let's go for it. And when you realize none of them, just a few of them had real data sets, validated data set, that's a shame for the field. We must not proceed in that way. So there was like a 2020-21 full of journal papers based on deep learning for recognition, classification, localization, segmentation for lung diseases. Few of them were correctly proposed. Radiology is a field that needs us so much, but we need to be serious about the kind of procedures we do when developing a learner and publishing. Here you can say that all the data sets are biased. Sadly, the clinical trials and, of course, the learning machines weren't trained with enough data. And here we are like LatinX people in a field dominated by different kind of ethnic features. But yeah, we are not included. So how can you tackle the problem of biasing, cognitive biasing, in your developments if you are not taking care about the sources of your data or the design of the studies underlying the systems you are going to develop? Think about the system of command and control. How can I develop a system in command and control without any proper knowledge of what the dynamics in my country, and specifically speaking, the environmental variables surrounding this? So this is an example on how can we avoid problems with ethics through a very carefully designed of experiment, to a very carefully designed of the training, test, and validation data set. But most important than that, working together with the humanities medical doctors, and people involved in the application. So our responsibility for decision-making based in artificial intelligence system goes to the fact that we need to work together with the people surrounding us. Well, so I would point to important stuff for me. As you can tell, this artificial intelligence is not only deep learning, machine learning, but also reasoning. So I'm obsessed with reasoning, and I'm obsessed with measure. But once you measure the probability of success or the probability of an event, you are fully open to understand the amount of information. Previously, I was asking you to take care of the design of your experiment, but yeah, why not go through statistics and probability and then measure how informative is your data set or the knowledge you have about the problem in order to design? For me, information compression and information validation in terms of entropy help us a lot to try to build reliable systems. Mathematics behind this invite us just to construct a model, but also to measure the complexity and, of course, avoid any possible problems in prediction. Remember, when I mentioned a conscious human, anticipation, prediction is the key for intelligence. But what if you are modeling something that has never happened? You don't have data. You need to be clever than that. So starting by building concepts in terms of rules of knowledge, uncertainty model, compression of the information based on variables, categories, and then reasoning inference will be a really good option for the artificial intelligence engineers too. Well, so I want to acknowledge my PhD students from the Colombian Air Force, and this system is critical for my country. We are in a geopolitical position, very interesting for the globe. We like to understand the dynamics of the atmosphere and the relationship with the dynamics in the air traffic system. Social, economical impacts depend on what we do because of, that we have so many products to export, some of them legal, some of them not. We have a biodiversity to protect, but we have several threats and risks to avoid during the operation. So what we do, not just getting a bunch of data, we think about the problem. So as you can tell, we decided to add qualitative variables to the functions of command and control our country. We decided to add different kind of sources of information from qualitative data, of course, such as news, international relationships, and then, of course, when we speak about this qualitative behavior, we may add natural language processing to the system. So we started to build in 3 different domains and 3 different levels this system. So we think about the strategy, we think about tactics, and we think about operation. One example of the different variables we have for command and control systems is the meteorology. In a very highly complex terrain, such as Colombia, the dynamics of atmosphere are changing. We do have information from satellites, so we need to deal with the extraction of information and segmentation of a different kind of meteorological data, and then use it for trying to warn different risks that may be added to our command and control systems. And of course, we have the cinematics, the dynamics of different aircraft. So we need to recognize pattern of these aircrafts in order to determine the performance of the aircraft that is coming from or going out of our country. And then once, for example, we know the kind of risk, the location of the risk, the speed of the risk, and then we have the information of the kind of aircraft we have, we may get into a reasoning system. So what I'm doing here is to add several layers of understanding. Strategy, tactics, operation, but we are also doing reasoning, intelligence, natural language processing, machine learning, and deep learning, helping out for the same purpose once you understand clearly what you are going to do, and of course the temporality of the problem. So in summary, what we have is a system in a multi-layer, multi-domain that allows us to reproduce the expertise of several people. So we had to go through a panel of experts in order to recognize the nature of the risks at a strategy, but we also had to go through a panel of pilots that allows us to determine if the cloud that we already segmented was as risky as we may claim with our algorithms. The other applications here is the drones that I showed you before. So we needed to detect if we had foreign drones to very close to different assets in our military bases. So we needed to extract features, and we needed to try to differentiate it from a bird or a helicopter or a plane. So we had to work through that. We use different kind of signals, radio signals, visual signals, thermal signals. So we needed to compose everything so our system is reliable and go to deployment. Same for intelligence. We do have a bunch of images, but the most important thing is not the amount of images. It's the kind of information the human being, the expert in intelligence, extracts. So this framework is from Michael Street from NATO, and this is the way they work, and this is the way we work for extracting the information from different kind of images and intelligence purposes. But as you can tell here, the different layers are the difference between a successful system and a non-successful one, such as I mentioned for the COVID. So we need to reunite all the possible outcomes and then all the possible strategies. Just to finish, my favorite application in medicine. So we work for humans, we think from science. We truly believe that we are not going to replace the physician. We need to help them in order to stay taking care of you in your bed. So for radiology, we developed a system that helps the radiologist to locate different kind of lessons. This one is not already deployed. People here are working to deploy it free for our nation. But we went from the detection, localization, and classification to a beautiful idea. So Dr. Alejandro asked me, Lucia, what if we can build a multivariated model to predict the outcomes of a patient? So he wanted us to use biosignals such as electrocardiograms and oxygen, also the images, clinical records, all the variables you can mention. And he wants us to build a system for him to prioritize the attention of the patients. And that's a responsibility, because I can tell if you are going to die, if you're going to be intubated, or if you're going to recover. And the priority of your treatment may depend on the systems and the models we are working to build. Example, you can tell there. So one of my students says, Lucia, there is a deep learner that already understood how to locate the points in an electrocardiogram. I said, great. Deep learning, how many subjects? 70. Can I rely on that result? That looks beautiful. That's a paper that was already published like 2 months ago. Can I deploy a system like that? I don't think so. I need to take care about the number of subjects, the qualification of the data set. I need to get the data to my medical doctors. I need to carefully review the results in order to train a model. Once trained, once validated, it would be in the hospital. So the responsibility of this is not only pattern recognition, is the possibility to change life and performance of your systems. Recently, we got funding for a project that we love. It is focused on mental health. So we are quite good on recognition of emotional states. And we like to call this the Olivia. And we will understand how can we help people after the pandemic that got a lot of stress, a lot of mental illness and disease, by helping the psychologist or the psychiatrist on monitoring your emotional state. People commit suicide, people get very, very ill, and once you have wearables, you have different kind of sensors you can monitor. you can use this to get into a very special application to see if you are changing your mood and if you need to go straight to the doctor because you are getting complicated. So the decision-making systems, to summarize, are asking us to provide not only a technical solution, but also a clever revolution of engineers that working together with transdisciplinary way of thinking under consciousness about the responsibility of the deployment of your algorithms, and then the ethics behind the decision-making for human well-being. That's the important key. And I want to open the invitation for the Latin American people of not getting technical. We come from a very beautiful region of the globe, and we do have skills in reasoning and understanding. We should not waste our time just getting technical and training. We should think about the nature of the human being. We should think about the way of provide solutions, and then, of course, perform better understanding of the world through artificial intelligence. Remember, the domains are the technical, tactical, operations, strategy. 3 different kind of levels. 3 different kinds of understanding in terms of reasoning, knowledge, information, and data. And of course, the sense of purpose. So this is what I wanted to share. We are HuMath. We want to work for humans and think from science. And I hope you enjoy the rest of the conference. And of course, if you have any questions, there are so many papers that support our work and our way of thinking. So thank you very much.
Thank you, Olga Lucia. So now we have the Q&A. Do we have questions in the room? Online?
Hello. Very interesting talk. Regarding incorporating expert knowledge into the systems, there are many ways in which we could do that. Meaning we could do it based on changing the structure of our models, changing the experimental design, or just by supervising the models with expert annotations, for example. So based on your experience, what's the way in which we can maybe start moving towards like a middle ground? Moving maybe from the deep learning models, how can we move towards incorporating this expert knowledge?
Thank you. Thanks for your question. I love it. The first thing we need to start thinking is that deep learning is not the ultimate solution for our problems. My favorite formula is based on the complexity, so we need to take care about the mathematical sense of the complexity of our models. Are you familiar with the work of Aurora, with the deep, ground truth deep neural networks and the autoencoder-decoder architecture? So first thing we need to start thinking is that deep learning is not the ultimate solution because of the complexity and, of course, the dependency of the data set. That's the first thing, but it's very useful. We love it. It's very useful. The second thing that I like to do is to mix quantitative research methodologies with qualitative research methodologies. Qualitative research allows you to work in triangulation, case studies, service, and extracting from experts through interviews. So interviewing is a nice process that you can go through, and that's the way we extract the needs for the outcomes of the algorithm. For example, if you go through a physician expert in internal medicine, asking about the lungs, I'm going to use, can you project this slide, please? Yes, thank you. That's a suitable example. So you have a lung over there, you have a thorax, sorry, and you ask him about that image. Internal medicine doctor will ask you about the location and the quantification of a lesion. but radiologists will look for something different. So if you're developing an application for radiology, the questions are going to be completely different than from internal medicine. So my answer to you is use qualitative and quantitative techniques of research. Talk to the stakeholders, ask them to address and get into a consensus. Read the literature on expert systems, not just in deep learning. Expert systems is a very good source of information. And finally, and I was going to forget to tell you that, measure carefully the outcomes of your algorithm. Some people is used to measure accuracy, recall, and that's something that is meaningless for a decision maker. The decision maker wants to know how sensitive the algorithm is, how sensible, how precise, in a very different manners. It's not the same when you are having a cancer application and you miss one and you avoid treatment for that person and suddenly dies. And if you are doing counting candies or recognizing different kind of nice figurines or having the difference between a cat and a dog. So the responsibility goes into the understanding and the proper measuring of the metrics of the algorithm. Another step that I really would love to share with you in terms of the responsibility of deploying these kind of algorithms is a combination of a good metric with the design of the algorithms. In Colombia, we do have 55 million people, I guess. So we have different kind of representations. And the ethnics are located specifically in certain parts of the country. In order to provide a system that generalizes, I should include them. But what if they are not part of the clinical trial? So I may try to find a way to be honest and say, okay, my algorithm works for this population, and we may look in the future for a different kind of population.
Thank you. We have another question, I believe.
Yeah, thanks for your talk. It was really interesting. About the COVID studies, actually, in a paper published in Nature, they found like from 2,000 papers published, not one of them were actually practical, like for clinical practice. They were unuseful at all. Yeah. So we worked a bit on that, and actually we are going to present a paper on one of the workshops about this. It's really interesting. I wonder if you have any. You talked about a little bit about evaluation, and if you have anything to say about how can we bridge such metrics that we usually compute on data sets, based on data sets and the labels that we have, with the outcomes that we really want to achieve. Because sometimes all we have is accuracy, recall, or precision, but what we actually want to have is another thing that's more like human related, not directly measurable.
Well, thank you. I refuse to think that we only have recall, precision, and accuracy. So there is different kind of ways to measure it. And I will call to, I don't know if I really have this here in my slide, my favorite equation ever. My God. Well, there's something that is called probable guarantee of learning. And it depends on, more or less like this, it depends of when you set a problem, you mean you need to define an epsilon that goes to your real life error, and you need to define a delta that goes to your training error. And you have the H, that is the hypothesis class, which is more mathematical concept here, I apologize. And the hypothesis class is the kind of family of functions that your learning machine represents. And in terms of the Babnik-Chernovsky's dimension of the learning machine, you may set a bound for this sample size. I had this discussion with the epidemiology people, and they say, okay, for the clinical trial, we need 600 subjects. So good to hear, but for my learning machine, I need at least 5,000. So mathematically speaking, you need to set up the boundaries for your learning machine, and then you may realize the size of your set and trying to figure out what would be the compromise between epsilon and delta, instead of just looking after going down with an function, a cost function. So that's the way of thinking. I'm always asking my students to say, okay, if we want to solve one problem, we may use different kind of sets or different kind of data sets, learning machines. So you can solve them, but you're going to need a different kind of data set or the different size of data set. So this equation is mainly the guide for me to procedure or to establish a procedure. That's one way. Another one is to, instead of going hard on deep learning, you may simplify the problem and say, okay, what we need to do first, determine if yes or no. Oh yeah, that's just 2 classes that we need to recognize. And then if yes, so you're good, go home. If not, oh my God, you have pneumonia from virus, and that's a different pattern, that pneumonia from bacteria. So, oh my God, so we need these 2 classes. Okay, go. If it is bacterial, oh, that's going to get complicated. Doctor, what kind of patterns should I recognize? And maybe the learning machine is going to be less complex, but you're going to have a very accurate. Instead of just try to train a learning machine like a deep learning with 15 classes, you may go deeper into a problem. Another key for that is use the autoencoders. I love them so much. I love them for reduction of dimensionality. I love the talk of Maria because they are the top inspiration of nature. We compress naturally information. So what if the task you go to do first is to learn the data? You will immediately find the features, and then you may project them to a different n-dimensional space and simplify the task of learning. So my advice, and of course my cover for everything, is the mathematics behind the learning, and of course the guarantees that I can provide to my data set, and of course the kind of problem we are posing, because there are so many ill-posed problems. And there is a paper in Nature that says that not all the data sets can be learned. So not everything is learnable, and learnability is a field that I am so interested in.
Thank you. So we have another question? Yes.
Yes. Do you think then that deep learning models will be less used in the future with this kind of approach you propose? What do you see the future of these deep learning models?
Sorry, can you repeat? Stand up, please.
Yes, sorry. Do you think that deep learning models will be less used in the future with this kind of approach you propose? What do you see the future of these deep learning models?
Yes, definitely. We use deep learning, but we don't give them so much responsibility. So we use them. They're amazing, fantastic. We like to transform them. We like to transfer them. We carefully choose what we want to do. We love GANs. We do everything. So these kind of algorithms are part of what I propose, but they don't get so much responsibility. We need to supervise them. We need to get from them what we need. And of course, on top of that, at the strategy level, we need to have something more related to the reasoning. And that's the way we work. So we definitely have deep learners here, but.
Thank you. I have one more question for you, Lucia. Great presentation. Thank you.
Thank you all. And of course, I will
have
be
one
very
question
happy.
for you.
Yes. So share what the students do. And of course, I am very happy to provide you insights and of course, provide the evidence behind of this. The journal papers are very useful for that. So it's not just publish and perish, but it's publish what is important. So that's
Sounds good.
Thank you.
So for your presentation heavily focused on being data-centric and knowledge-centric, which aligns to a philosophy on AI, right? There are different people that are backing up that philosophy that we should be data-centric and knowledge-centric. But clearly, deep learning has been evolving to the unsupervised deep learning, where we don't have to have that data-centric approach. And we have seen successful results. Successful results that are not only to specific tasks, that can be to many different tasks, which is the opposite to what you're proposing. One of these cases, the latest probably is BERT, and then GPT-3, and GPT-3 is one of the most recent ones that, although it started as an unsupervised deep learning, very deep learning, like we have more than 100 layers of deep learning there, it started with Wikitext data set. Now we can actually deal with code. It can help to actually decoding. We don't have to change anything of the architecture. We just have to change the input, how it is being trained. What are your thoughts in these two different opposite views?
Well, my thoughts about it is that even if we come up with these kind of learning machines, there is a society that is asking us for the use of that kind of object. So while we are walking through super powerful machines, the results have to come up to the people, and there's regulation about it. So we need to work in two different senses. Even if we got the powerful machines, we have check this journal, this Artificial Intelligence and Society, and we do also have regulation in Europe, and we have regulation in Colombia, and we have regulation. So once your learning machine is going to affect people's lives, we need just to take care of that. What I think is amazing and it's exciting. I myself do have a powerful machine in my own laboratory, and I do like to play with very complex models. But when come up with the deployment, I guess that as explicable as possible, as open as possible, as ethics as possible, our practice may be successful. So I guess that we as mathematicians and engineers can work in a very sophisticated machines with no risk of harm. That would be great. But once their application goes to society, we are going to be judged by our actions, and we need to acquire that responsibility.
Thank you, Olga Lucia.
You're very welcome.